Hi everyone, so you should be looking at your notes packet that we handed out a couple days ago. And right now we're going to be on the page that says arc length, and what you want to do is label that section 12.2. Okay. So arc length is actually in linear units. So for example, if I want to know the measure of arc QR, we really do that with a degree. But however, if I wanted to take a piece of string and see how long that arc is by pulling it apart of the full circle, that's what I'm actually looking for. So it could be in centimeters, meters, inches, feet, whatever. It's in linear units. It's not in degrees. So there's a formula for finding arc length. So if I wanted to find the arc length of our QR, I would have to find the measure in degrees of the whole entire circumference. So I would have to find the measure of this arc and divide it by the actual entire 360 degrees, because that's the portion of that whole entire circle that represents, and times it by the circumference of the circle. So recall that the circumference of a circle is found by taking pi times diameter. Or if we're given the radius, then we take 2 times the radius times pi, because it's 2 radii equal a diameter. So if we could first start by looking at all these numbers, and for some reason they're missing the arc symbol, so let's go ahead first and put all the arc symbols above it, because we're looking for the arc measure. And that goes for all of these down here as well. Okay. All right. Now, the first thing we're going to do is we're going to find the measure of each arc. So that's separate from arc length. We're not going to be finding the arc length until problem number 10. All right. So to get the arc measures first, let's go ahead and utilize this information and go ahead and label our picture. So in circle X, segment WS, segment VR, and QT are diameters. Again, they have to go through the center of the circle, which they do, so they are chords that go through the center, which are diameters. Now it says the measure of angle WXV, so angle WXV is 25 degrees. I'm not sure why they don't have the degree symbol, but that should be there. And angle VXU is 45 degrees. So let's go to angle VXU, which is 45 degrees, and put that here. Okay. So they want us to find the measure of each of these arcs. Okay. Well, if you look, these are all central angles. So the central angles are equal to the measure of the arcs that they intercept. So for example, since WXV is 25 degrees, that means the arc that it intersects, VW, is also 25 degrees. And if VXU is 45 degrees, then arc VU is 45 degrees. And if this angle here, QXR, is 90 degrees, then arc QR is also 90 degrees. So if we just go around the circle, we could see that these two are vertical angles here. So vertical angles are congruent. So this is also 25 degrees. Okay. If you look, that this right angle is a vertical angle to this entire angle here. And that means together they're 90 degrees. And if this is 45 degrees already, then that means this is the remaining 45 degrees. Which means that arc TU is also 45 degrees, and arc RS then is 25 degrees. Okay? So that leaves these two right here. So you could do this a couple of ways here. You could say, well, I know that VXR, this whole angle is a semicircle. So if all of it equals 180 and this is already 90 degrees, then this remaining part together has to be 90. So 25 minus 90 will leave us with 65 degrees, which means its vertical angle is also 65 degrees. Okay, so now we could just go ahead, and if you look here, this is 65 degrees here for this arc, because again, it's a central angle and it's equal to the intercepted arc. This also is 65 degrees. And we can go ahead and answer all of these questions now. So the measure of arc QR is 90 degrees. The measure of arc QW is 65 degrees. The measure of arc TU is 45 degrees. The measure of major arc WRV. We have to be careful here that we go in the order of the letters. So from W passing through R all the way to V, we have to basically add up all of these measures up until we get here. Now if you look, it's almost a full circle, but we just take out 25 degrees. So instead of adding up all of these individual arcs, you can actually take 360 and subtract 25 from that. So 360 minus 25 would give us 335 degrees. Okay. All right, moving on. We have the measure of arc SV. So from S to V, it looks almost like a semicircle. But again, so we could add up each individual arc measure that we've already calculated, or we could take 180 degrees, which is our semicircle, and subtract from that to 25 degrees, which is 155 degrees. Okay? So there's a couple ways you can do that. And that's just what I did. It's just easier to subtract one number than to add three individual numbers. All right, now we're talking about major arc TRW. So the measure of major arc TRW in this direction from T passing through R all the way to W. So we could add, if you look, this is a semicircle here from Q to T plus another 65 degrees. So we have 180 plus the 65 degrees. So we have 245 degrees for that arc measure, okay? So what we did is we basically laid the groundwork for what we're going to do in the next section, which is find the arc length. And the reason we did that is because to calculate the arc length, we need the measure of the arcs, which we just found, and then we're going to have to divide that by 360 degrees because that's the portion of a circle that it actually represents, and then multiply it by the circumference of a circle. So what we're going to do, we're going to be using a lot of these answers down here as part of our work. So for example, it's telling us that UX, so that's the radius. So if our radius is 10, find the length of each arc. So that's the arc length. So if our radius is 10, that means our diameter is 20. So the circumference of our circle is pi times 20, which is 20 pi. So for each of these examples, our circumference is going to be 20 pi. So we're going to have to remember that because we're going to have to multiply our section of the circle, our portion of the circle, times our circumference, 20 pi each time. All right. So in order to find the arc length of arc QW, what we're asking is if I were to go ahead and take a piece of string from Q to W and straighten it out, I want to know how long is that? How much of the entire circle, the circumference, is it? So what I'm going to do is I need to use our formula. So let me just go ahead and change that pen. So the arc length, I'm going to abbreviate that as AL. Our arc length is equal to the measure of arc QW, which is 65 degrees, divided by a full circle's 360 degrees, and I'm going to take that ratio, that fraction, and multiply it by our circumference of the circle, 20 pi. Now, we actually want to make sure we write our answer in terms of pi, which means we leave pi in our answer. So we're not going to do anything with the pi in our calculator. As our final answer, we're going to leave it. So if you take your calculator right now and in parentheses put 65 divided by 360 in closed parentheses and multiply it by 20 pi, we're going to get 65/18 pi. And that's in lowest terms. Now you probably got a decimal, so make sure that you hit math, enter, enter on your actual calculator. And then which you're going to get 65/18, and then we're just going to leave the pi in it as well. So that is the arc length. And again, this is linear units, so it could be pi meters, it could be pi feet, whatever. So it's just units. Okay, so that's our answer for arc, the measure, the length of the arc QW, the length of the arc. Okay, let's look at arc TRW, which, if you look, we found right here in problem 9. So since the measure of arc TRW was 245, that means the arc length is going to be equal to the measure of that arc, 245, divided by 360 degrees, which is a full entire circle, right? And we're going to multiply that by our circumference, which is 20 pi. And again, if you go ahead and put this in your calculator in parentheses, then multiply it by 20, hit math, enter, enter, you're going to end up with 245/18, and then just leave the pi at the end. And this is units. Okay? And feel free to pause anytime to make sure, pause this video to make sure that you are getting this in your calculator. And if you're not, then make sure you ask for help and then go ahead and press play again until you know how to use your calculator. All right. So let's go ahead and do number 12. So for number 12, we're looking for the arc length of arc WRV. And if the measure of arc WRV was 335 degrees, that means we're going to use that 335 degrees divided by 360 degrees. We're going to put that in as a fraction in your calculator, multiply that by 20, and then since 20 pi is our circumference, we know that we're going to have to hit math, enter, enter again without the pi in there and figure out what 3/35 3/60 times 20 is. Math, enter, enter that, and we should get 335/18 pi is our answer. Okay? And finally, the arc length of arc SV. If we look here, we found the measure of arc SV, which is 155 degrees, divided by a full circle, 360 degrees, timesing it by the circumference, which is 20 pi. So if you put 155/360 in your calculator, times it by 20, and then hit math, enter, enter, you're going to get 155/18. And then we're just going to go ahead and leave the pi in units again. Okay? So that's it for arc length. So your homework for this section should be your 12.2 worksheet. Okay, thank you.